Hello, welcome to Team Clock's final presentation for our FHIR application for an existing clinical decision support system for hospital discharge decision making. So the first order of business is understanding what our problem was. So say somebody checks into a hospital and undergoes a surgical procedure. After the fact, it's up to the physician to decide when to send them home. So this provides a sort of a Goldilocks scenario. So discharging a patient too soon can lead to readmission, which is hard on the patient's health. And discharging too late occupies hospital resources, beds, and thus unnecessary finances. An ideal solution to this problem is finding the perfect medium of discharging a patient such that they can successfully recover at home with an unlikely chance of complications leading to readmission. Up until now, the discharge decision has been based purely on the physician's judgment. However, Dr. Cox and Dr. Sweeney have developed a clinical decision support model using actual patient data in order to help physicians make this decision. The goal of our project was to utilize this model to build an application which pulls in patient data from a FHIR server, runs the model, then displays the output recommendations to our end user, or the physician in our case. We were given an encoded Excel spreadsheet with examples to work from. We were able to successfully create a web app that does exactly that using the model we were given. On top of accomplishing our primary goal, we have developed a code base that is well factored, fully commented, and provides a full set of documentation outlining goals, history, tech stack, code, and the architecture we used. While our app outputs the appropriate data, we have left charting the results to the next team working on this project. This project encompassed a good portion of research that can be broken down to four main areas: Smart on FHIR standards and frameworks, Cerner's EHR system and Smart on FHIR compliance, Kramer's FHIRNet API framework that we used, and .NET Core. Our OEMs initially wanted a Smart on FHIR application to integrate with Cerner EHR. We had planned on using CDS hooks with suggestion cards and the Smart on FHIR client.js library. However, we quickly ran into some issues. Although Emory uses Cerner EHR, the version currently being used is not Smart on FHIR compatible. Furthermore, Cerner's latest EHR version does not support access to all the resources required by the model. We figured this out after diving into Cerner's integration and certification specs. An application must be in the Cerner App Store in order to integrate, and the application must first pass certification to be listed in the App Store. There are several requirements to obtaining the certification, and the process can take several weeks. After researching, we landed on Kramer's FHIRNet API to assist our client in reading FHIR data. It is currently the first long FHIR client framework for .NET, and the only downside is it's not very well documented. So much time was spent reading through source code to determine exactly how it works. We did in fact figure it out and are successfully using it for integration in our app. And finally, .NET Core. Though we built our application upon it, nobody on the team had prior experience using it. Thus, research was conducted on the dependency injection system, project configuration files, and how to run non-.NET Core frameworks, like Kramer's mentioned in the last slide, on top of .NET Core.
Our application is built with the following tech stack: Microsoft Azure Web Apps, our hosting provider; C#, the language that we use for development; ASP.NET Web API, this is a simple web service framework that we use to power our web services; the FHIRNet API, the open source framework that we use as a FHIR client; Angular, the front end, and MVC, the Bootstrap that we use for CSS and responsive grid.
Our project is currently deployed as an Azure web app and can be seen at the link listed. This hosting infrastructure is set up so that our OEMs can use a custom domain name and SSL certification if they so choose. Now that we've had a chance to discuss the background of the application, we will walk you through a working demo. If you enter the URL provided on the previous slide, you should hit a home page that looks something like this. Notice we have a patient search with a short description. First, let's search for a patient by ID. We will enter 1 in the search box and then press Submit. Our search parameters return a match. We see the patient with the matching ID of 1, along with some other identification information such as name, address, gender, and date of birth. Let's select the patient by clicking the corresponding button. Here we find the results after running the model calculation on the given patient. As you can see, the results are broken down by day, displaying the probability of readmission, the error with upper and lower bounds, and the actual discharge decision. Let's press the button to search for another patient. This time, let's search by patient name. We will search for Sophia Doe, our last example, and then press Submit. You'll see that this also returns the results we expect, and selecting the patient will reveal the decision breakdown as it did when we searched by ID. Now let's head back to the search screen. Now let's try to submit without entering a patient ID. Notice that we get the appropriate error message. If we drop down and try to do the same thing when searching by patient name, we also get the appropriate error for each missing piece. You will also notice the About tab at the top of the screen. Clicking on this will reveal a detailed breakdown of what the tool does and why it is necessary. Finally, let's head back to the home page. This is the conclusion of the demo portion of our presentation. One of the most important factors in the development process of this app is quality assurance. Our OMs gave us example calculations that start with the daily values retrieved from the FHIR server and work all the way through the daily probability of readmission, the upper and lower bounds for error, and the actual decision itself. We have thorough unit test coverage to ensure our calculations match theirs. Moving forward, there is some room for improvement. The first is live integration with Emory's EHR. This includes ensuring the necessary data is actually input into Emory's EHR, all of that data is encoded as the model expects, and finally to update the ending date from the last observation date to be the current date. We had to do this little hack in order to actually test the model using our test FHIR server. Next, there are a few code enhancements. This includes moving hard-coded configuration variables to a .NET configuration file and moving hard-coded model coefficients and default values to an external database. Here you will see our final project plan. The far right column displays the % complete on a task-by-task basis from the project. And here you'll find our corresponding Gantt chart. And finally, a look at the people behind the scenes. Rob Reagan was the project manager and lead developer for the project. He was responsible for writing nearly all the code and documentation while keeping the team organized and on track for success. My role was as a mathematician. I worked on breaking down the model calculations and worked in person with Rob in order to put these calculations into code. I also compiled the final version of our presentations. Raymond Toscano reviewed code and performed quality assurance. Mian Ahmad contributed on several presentations while also doing code review and QA. And that is all I have from Team Clocks. Thank you so much for watching.